Hello, YouTube. This is Umozo3. In the previous couple lessons, we've been learning about a sorting algorithm called bubble sort, and we said that basically bubble sort is a very simple way of sorting a list. It's a way of sorting a list of elements that's sortable. Okay, and in the previous lesson, we learned about basically sortable elements, and we said that we can use the less than magic method, the less than and greater than dunders, in order to sort person objects or point objects or hamburger objects or coat hanger objects or anything that you want, okay? But what you would have to do is you would have to specify how that works in the less than dunder. So what we did is we reviewed this person class, right? And we created a person class, and where did we do that? We did that right here, okay? And we have a constructor, and we said that a constructor is a special type of function that instantiates an object, right? Creates an instance of a class. And its work in doing that is to usually assign the values of the instance variables. So here we have two strongly private instance variables characterized by two underscores before the name of the instance variable. And we would go ahead and assign the name and age to the n and a parameters that are passed into the constructor when the object is created. And then we have properties and setter methods, and we talked about these in lesson 40, and we reviewed them in the previous lesson. We said that basically these types of functions are responsible for returning or modifying the values of strongly or weakly private instance variables. And what they would do is they would take the same name as the instance variable, and you would characterize them as being an instance method by saying self in parentheses. And then if you were talking about a setter method, you would also need to pass in the new value that that instance variable is going to take. But then you would either say return self.name, or you could say self.name equals n. And then you would need these decorators on top of the functions, on top of the function headers that you can see here. And then we also have the same thing for the age instance variable as well. And then we also have a string dunder, right? A string function. And what we would do here is it's an instance method that represents a string. It's a string representation of an instance of a class. So we would return the name instance variable for that particular instance, and then the string representation of the age instance variable for that particular instance, and then the words years old, okay? And then we can also have a have birthday method, which increments the value of the age instance variable by 1. But the important ones are right here, the less than and greater than dunders, okay? And these are instance methods that also accept another instance of the class, right? So if we're talking about a person object, not only are we acting on a person instance, but of course we also want to compare to another person instance, right? I'm not just less than, I'm less than someone else, or I'm greater than someone else. And the way that we define me being less than someone else is if the length of my name is less than the length of the other person's name. So we would just return the Boolean length of self.name is less than length of other.name, okay? And then we can also define, well, what does it mean for me to be greater than someone else? Well, that means for someone else to be less than me. Well, what does it mean for someone else to be less than me? It means for their name to be shorter than my name, okay? So that's how we would define me being bigger than someone else. You can define a dunder with another dunder, and that's what we do on lessons 120, on lines 122 and 123. And then we also have this get item dunder, which we've brought up once or twice in the past. But what we do is this basically allows us to treat an instance of a class as though it were a dictionary that we could feed a key into. And so basically here, my item symbolizes a key. And so basically, if we say for a particular instance of a class, so if we say u equals person of Tom, 81, what we could do is we could uncomment some of the lines down here, but what we could do is we could basically say print u of name, okay? And so basically what that would do is, because we say if the key is equal to name, then return the name instance variable, okay? So what this does is this basically allows us to treat an instance as though it were a dictionary that we can pass keys into and get values out of, okay? And so the keys would be name, age, or dog. This is just a silly one that I made to demonstrate the functionality of this get item dunder, and I want to have an example of it, okay? And the values would be what it returns, so like self.name, self.age, 400, not valid. So hopefully that's clear to you. But what we could do is we could say print u of name, and that would return the name instance variable. So now if we go ahead and run this code, we would go ahead and get Tom, okay? And this 72 is from something else. I want to demonstrate this in a minute, actually, but we're going to go ahead and delete that for now. But you get Tom at the top, right? And that's the first thing that we're printing on the console, because that's what we wrote right here. We said print u of name, and we get Tom. What if we said print print 2 times U of dog, right? So then what if we say, well, if the key is dog, then we want to return 400. So this will go ahead and return 800, right? And so we print 800 on the console because 2 times 400 is 800. And then we demonstrated bubble sort, and we passed in a list of person objects, right? You don't have to just pass in a list of integers or floats, but we're saying that any class can be sortable. Any type of object can be sortable as long as you define a less than dunder and a greater than dunder. So hopefully that's clear to you. But we would go ahead and say my people equals UVWXYZ. So we passed in these 6 instances of the person class, where we created them by passing in a value for the name instance variable and then a value for the age instance variable. And then we could basically go ahead and say something like my people equals bubble sort of my people, or something like that. And then what you could do is you could say for Z in my people, print of Z. And then basically the effect that we saw is that basically these person objects are sorted according to the length of their name, because that's how we defined one person to be less than another person in our less than dunder. So hopefully that's clear to you. So in this lesson, we're going to be talking about insertion sort, but one of the things I wanted to say first is that Lambda functions don't have to have any inputs. So in the previous lesson, we made 3 Lambda functions: my function 1, my function 2, and my function 3. And they all have inputs, right? So we either said lambda A or lambda B, C, D, E, F, right? Or lambda X, Y, okay? But what we can do now is we can delete all of those, because I want to talk about functions that don't accept any inputs. So here we have my function 4 equals lambda colon 77. So this is an example of a lambda function that doesn't accept any inputs, and it just returns something. And it's a lambda function with no inputs, and I guess you could say one output if you want, right? Either you're returning something or you're printing something, right? So my function 5 would be a lambda function with no inputs and no outputs. This is something that doesn't accept anything, and it doesn't actually even return anything either. The output of it would be none. So what it does is my function 5 is not equal to something. It's not equal to an output. You don't set it equal to a variable. You call it and it performs an action. So hopefully that's clear to you, the difference between outputting 77 as a result and printing something as an action. So what you could do is you could say s equals my function 4 minus 5, and then you could say print of s. And so now if you go ahead and run it, you would get 70. Let's see, what's the issue here? So we can't call my function 1 anymore, right? Because I deleted that. But now if we go ahead and run this code, you get now what is x? Okay, it doesn't know what x is. Sorry about that. So now if you go ahead and run it, you get 72 on the top, right? Because it returned to 77 when you called that lambda function that didn't accept any inputs. Okay, and then you could have also just said, what if you said for counter in range of 5, and then what if you say my function 5? Okay, and so now you're not setting my function 5 equal to something, you're just calling it. And if you call it 5 times, then it says my name is Steve 5 times. So hopefully that's clear to you. And then we also talked about the pass keyword. So this does nothing at all, right? This does nothing. So if you hover over it in this integrated development environment, it says pass is a null operation. When it is executed, nothing happens, okay? It is useful as a placeholder when a statement is required syntactically, but no code needs to be executed, okay? So what if you said, what if we said print nothing, define print nothing of int x? And then what if we say pass, and then we could say return 5, right? And then you could go ahead and say print nothing of 10, right? And so basically this wouldn't print anything, but you would basically return just a number. And so now if you go ahead and run main.py, it would just go ahead and return 5 on the console. But anyway, we can talk about insertion sort now. So essentially what we can do is we can say that insertion sort is a more efficient way of sorting a list. Okay, so we've already talked about sorting integers or sorting floats or sorting strings lexicographically or sorting person objects according to the length of their names with bubble sort, but now we can do the same thing with insertion sort. So we have very, very similar doc strings. This function accepts a list and returns a version of the iterable where the elements are sorted in ascending order. This works for both numeric and lexicographical elements, okay, and also for any other type of elements and, okay, any other any other type of sortable elements. Okay, so hopefully that's clear to you, and that's what we spent the last video talking about, is how we use the less than dunder to sort any instances of a class, okay, any type of class. So parameters, it's just going to accept a list, and the reason why it has to accept a list and not a tuple is because tuples are not modifiable. What you could do is you could pass in, you could make a slightly different version of this insertion sort function where you do pass in a tuple, but if you're talking about passing in a tuple into this function, what you need to do is write a little bit more code where you would accept the tuple, you would make a list out of the unsorted tuple, you would go ahead and sort that list, and then you would make a tuple out of the sorted list, right? So if you wanted to make a sorted tuple out of an unsorted tuple, you can't modify the tuple itself, but you would have to basically have a list where you can modify that list, and then you can go ahead and return the tuple representation of the sorted list, since the list has the modifying functionality available to it and the tuple does not. But for insertion sort, we're going to say, remember the bubble sort was very, very simple. It's about 4 or 5 lines long. The insertion sort is maybe slightly longer, but it's also a little bit more efficient. So what we can do is we can go ahead and learn about insertion sort here. But if we go to insertion sort on Blackle, you can go ahead and look at the Wikipedia article, and it says insertion sort is a simple sorting algorithm that builds the final sorted array one item at a time. Okay, it's much less efficient than other sorting algorithms. So if you go into more advanced computer programming courses, or if you really do a lot of good software engineering work, you would really want to implement a sorting algorithm that's even better than insertion sort. However, we learned this one because this one is better than bubble sort. Okay, it does better than bubble sort, and that's what it says on this line. It's more efficient in practice than algorithms such as bubble sort. Okay, in the next video, we're going to talk about a third sorting algorithm called selection sort. So we're actually going to get less efficient again, but I just want to basically be able to compare and contrast 3 sorting algorithms. So anyway, there are some advantages to it, and it's simple enough to learn. So it's still one of the more educational ones, I would say, rather than one of the really practical ones that are used in industry. Okay, what you would do for insertion sort is you would say, oh, and the other thing I want to say about it is that when people manually sort cards in a bridge hand, most use a method that is similar to insertion sort. So I don't know how many of you play bridge, probably like 2 or 3% of you, but for those people, you're probably using insertion sort. So anyway, what you're going to do is you're going to say for q in range of 1 length of my list. So what we're going to do is we're going to select values of q that start at 1 and go up to the length of my list. So if you're talking about a list of 9 unsorted elements, you would start at q equals 1 and you would go all the way up to q equals 12. And what you're going to do is you're going to say key equals my list of q. So you're going to look at basically my list of 1, for example, okay? And so what you would do is you would say r equals q minus 1, okay? And so then what you would do is you would say for r, while r is greater than or equal to 0 and my list of r is greater than key, what we're going to do is we're going to say my list of r plus 1 equals my list of r. So what this does is we have a value of q, and then we have values of r that are less than q. So r is going to go, basically it's going to start just immediately before q, and it's going to work its way down to the beginning of the list each time. And what we're going to do is we're going to want to keep flipping elements as long as we have elements that are earlier in the list, that show up in earlier index positions that occupy larger values, right? We want to keep swapping them so that eventually we have a list that's in ascending order. And so that's what this Boolean is checking, is it's going to keep looking through the values of r before q, and it's going to say, well, if I have previous elements that are earlier on in the list that have larger values than like this value that is later on in the list, then I'm going to want to go ahead and do a swap. So I would say my list of r plus 1 equals my list of r, okay? And then eventually we're going to say my list of r plus 1 is equal to key, okay? And that's sort of the algorithm. And then at the end of this for loop, so once q takes on all the possible values that it could, what we're going to do is we're going to say return my list, okay? So hopefully that's clear to you. And then what we're going to do is, so that's the insertion sort algorithm. And so now what we can go ahead and do is we can test it for person objects, but we can go ahead and first do it for integers, okay? So what you could do is you could say sample list, and then I could have, what if I have gasoline prices in different states? So I say 291, 288, 304, 341, 326, 330, 335, 310, 304, 279, it's really cheap in that state. 320, and 3.08. Okay, and then what we're going to do is we're going to say sorted list equals insertion sort of sample list. So we're going to create a new list based on which is going to be a sorted version of the unsorted list. And what you could have done is you could have just stamped over it. So you could have just overwritten the value of the sample list variable. You could have just redefined sample list according to being the sorted version of the sample list itself. So let's just do that. And then what we could do is we could say for R in sample list, we could say print of R. Okay, we could do something like that. And so now if we go ahead and run it, what we would do is we would get a sorted list. And so you can see these numbers get larger and larger according to the insertion sort algorithm. And so the point here to recognize is we have another sorting algorithm available to us that is slightly more lines of code than bubble sort, but it's a lot more efficient. And so it would be better to implement insertion sort overall. Probably it would be better from a computer programming perspective because it's more efficient. And so now you have two techniques at your fingertips. You have bubble sort, which we talked about in a previous video. And now we have insertion sort, which we've talked about in this video. We say for R in range of 1, length of my list. Key equals my list of Q. R equals Q minus 1. While R greater than or equal to 0 and my list of R greater than key, my list of R plus 1 equals my list of R. R equals R minus 1. My list of R plus 1 equals key, return my list. Okay, and that's all there is to it. And you want to be careful with the indentations and the tabbing, right? In PyCharm and in integrated development environments like PyCharm, it's going to be important to have the right spacing here and the right tabs. That's something that is pretty specific. Okay, so what you're going to do is you can go ahead and verify this for numbers, right? And you can do this for floats. But you could have also done this for person objects. So now what we're going to do is we're going to go ahead and say my people equals UVWXYZ, just like from the previous lesson. But now instead of operating bubble sort on it, right, because when we ran the console previously, we did this with bubble sort and we saw that the names get longer and longer, but that was with bubble sort. So now we can go ahead and do it with insertion sort. So now if we go ahead and run main.py, we're still doing it with bubble sort. So now we would want to say insertion sort of my people, and we can verify that this works. So the point is that now you have two techniques at your fingertips to work not only to sort integers and floats and, strings lexicographically, but any object whatsoever. You can define one, toothpaste object to be less than another toothpaste object. Maybe you're comparing an instance variable like quantity full, right? And you would want to check to see if the quantity full of one is less than the quantity full of another. But the point is that you could sort toothpaste objects, right? So hopefully that's clear to you. You can sort anything you want, person objects or pizza objects or car objects or house objects according to how expensive they are. Okay, but you get to define that in your program. And so insertion sort, the point is to understand that it's more efficient than bubble sort, and that it's really not much more complicated, right? It's really not that much more difficult. And in bubble sort, we had basically a nested for loop, and then we have an if statement. And basically what the insertion sort does is it has a for loop, and then it has a while loop within the for loop, and it has basically two Booleans that it's checking for that while loop, rather than just one condition that we were checking in this Boolean right here. But anyway, we would say, while R is greater than or equal to 0, and my list of R is greater than key, and then we would go ahead and do the swap if we have a larger value that appears earlier in the list. Okay, and the reason why we have to talk about a list rather than a tuple is because tuples are not modifiable directly. You can't just pass in a tuple and immediately modify the tuple. You couldn't say my tuple of R plus 1 equals my tuple of R. You cannot do an assignment at a particular index position of a tuple, but you can do an assignment of at a particular index position of a list, right? The reason why this doesn't work for dictionaries is because we're talking about index positions like 0 and 3 and 5, right? We're talking about positive integers, right? Which we said range of 1, length of my list. So we're talking really about positive integers, right? And so if we're making those index positions, if we're making those keys, then we're talking about usually a list. And so we're talking about sorting a list, and we're saying that insertion sort is a more efficient way than bubble sort to sort a list of sortable objects, not just ints and floats, but also strings and objects in general, according to how we write the less than dunder. So hopefully that's clear to you, and we'll talk about another sorting algorithm in the next video. From UMills03, thanks for watching, and please subscribe.